Hello, Algebra 2A, and welcome to Lesson 43, Solving Systems of Linear Inequalities. Today, our only goal is to graph and solve systems of inequalities. A system of linear inequalities is formed by two or more linear inequalities. An ordered pair is a solution if it is a solution to every inequality in the system. And back in Lesson 36, we started to look at linear inequalities, and now we're going to start looking at what happens when we graph two linear inequalities. So in example 1, determine whether -2, -1, and 3, 1 are solutions to the system of inequalities. And then we're going to graph the system. Well, by graphing the system, we'll be able to tell where all of our solutions lie, and then we'll check to see if -2, -1, and then 3, 1 are in the solution set. So first we'll graph this first inequality. So back to how we graphed these in lesson 36. So we graphed the boundary line, which is y equals -2. So that's going to be a horizontal at -2. And since it's a less than, that means we're going to be dealing with a dashed line. And secondly, we look if we shade above or below that line. And since y is greater than, we are going to shade above. So I'll just kind of lightly, I guess, just kind of make some marks there where the shading is. And second equation, 2x plus y is greater than or equal to -2. Well, we'll get the 2x moved over, so y greater than or equal to -2x minus 2. And we'll graph that boundary line. Well, this would have a y-intercept of -2. And then a slope of -2, which means I'm going to go down 2 over 1, down 2 over 1, follow that pattern. And then I would check, since it's a greater than or equal to, I am going to make a solid line. I'll just do my best to draw that boundary line. And then lastly, we look y is greater than, so I'd go to my y-intercept and I am going to shade greater than. Now lastly, I'm going to kind of put in this pinkish purple. This is where the solution set lies. Anywhere where the graphs are overlapping is going to be where my solution set is. Now I'll go back and find out where are these 2 points. So -2, -1 is over here, which is not in the shaded region. 3, 1 is right here, which is right in the middle of that purple. So anything in that purple region is a solution to the system, so that would be a solution. This one would not be a solution. So in order to be a solution, the ordered pairs need to lie in that purple region. In example 2, we'll start looking at how we can use graphing technology also to represent these linear inequalities. So in example 2, we have in standard form x plus 3y is less than -6, and then y is greater than or equal to -1/3 x plus 2. So over here we would subtract the x over, then divide by 3. So both of these are going to have a slope of -1/3, which when we have two that have the two lines with the exact same slope, they would form parallel lines. So here would be our first inequality, and I can't see it here, but the little keyboard, if you click that, you'll get to use these symbols, less than, greater than. And then the second inequality, there it is. But as you can see, since they both have a slope of -1/3, they are going to be parallel, which is actually causing them, because the region of the blue is above, the region of the red is below, they never are going to touch, and they're never going to overlap. So that would bring us to, this one would be no solution. So there would be our final answer. They're never going to overlap. That means there is no ordered pair that fits both inequalities, which can happen. And let's take a look then at B. And taking a look at B, we put x minus y is greater than or equal to -3, and then y is greater than or equal to x plus 2. Since they both would have a slope of 1, they are parallel, but this time we do see the little purple overlap happening in between there. So anything in this region, any ordered pair that you find in this region would be a solution to the system. And here I just opened up the little keypad. You can see there's your less than, greater than or equal to, less than or equal to, that you can use graphing technology to graph these out as well. In example 3, you can also graph multiple beyond 2 inequalities, and you would again just keep overlapping until you get to, or keep shading until you find the overlap of all 3 of those inequalities. So I'll let you take a look at that one on your own. Example 3, we just have 3 inequalities, and we would find the overlapping region, which, since it's 3, is going to form a triangle. And lastly, we have example 4. Says 2 ticket prices for a 2007 New York Yankees baseball game were $62 for a box seat and $15 for a bleacher seat. Suppose you are a softball coach. You want to buy tickets for your team. You decide to buy up to 20 tickets and spend $600. Let X represent the number of box seats. So we'll write that down. X is going to represent the number of box. And Y is going to represent the number of bleachers. I'm just going to use the number sign or hashtag, and then Y is going to equal the bleacher. Write and graph a system of linear inequalities to represent all the possible combinations of box and bleacher seats you can buy. Now, I don't know if you caught it, but right here it gives us 2 limitations. You can buy up to 20 tickets and spend up to $600. So that would mean that X plus Y has to stay less than or equal to 20, because we can only buy up to 20. And then 62X plus 15Y has to stay less than or equal to 600. So those are our 2 limitations that we have. And the 62 would be the cost of the box seats, and then the 15Y would be the cost of the bleacher seats. So we're going to head to Desmos, and we'll take a look at the overlapping region for this example. So we put both of those in. We can see our first limitation, we have to buy less than 20 tickets, less than or equal to 20 tickets. And then our second limitation, we only have $600 to spend. So the red is all the combinations of bleacher and box seats that are less than or equal to 20. So like we could buy 10 of each, which would be this point right here. You could buy 20 of the one and 0 of the other, so on and so forth. And then the blue is our budget. So we only have $600 to spend. So inside of the blue, we have all of our combinations that will add up to less than or equal to 600. Now the overlapping region would be the ordered pairs that satisfy both inequalities. So inside of here, like for example, a point right here, which is 210, that's going to be 2 box seats and 10 bleacher seats. That is going to keep you under 600, and it's also going to be under 20. So those are all your solutions for both. We're going to take this idea later on and use it for a concept called linear programming that we will take a look at later on in lesson 54. But for right now, we're practicing graphing just 2 or 3 of these inequalities, and you're always looking, where is that overlapping region? Well, that wraps up our lesson 43. You are ready to take a peek at your Delta Math lesson 43, and you can go ahead and get started on that. And good luck, and we'll see you next time.